everyone, a card is randomly drawn from a standard deck. We're going to show that the events Jack and Spade are independent, and we're going to look at the rules for probability of events occurring together to find the probability of drawing the Jack of Spades. And then finally, we're going to answer, are the events Jack and face card independent based off our rules, what we've learned. So the first thing we're going to do is, here's your rules that we're talking about. There's rule 1 and rule 2. And these are probability of events occurring together. The first thing you want to know is, let's find the probability of a spade. So if you don't know cards, there's a total of 13 spades. So each of the suits have 13 in them. So that's going to be 13, and the total is 52 out of 52. All right, which equals 1/4. Now let's do the probability of Jack. We're going to do, to see if they're independent, we're going to do probability of a spade given that we drew a Jack. All right, so basically what you're looking at on this is you're just looking at the total number of Jacks. So we have 4 Jacks. That's your total, and only 1 Jack is a spade. So that gives you 1/4. Since the probability are the same, that means they are considered independent. So basically we're looking at this. We're letting B be the spade and Jack be the A. Okay? So since they're the same, that means they're independent. Now we're going to show how rule 2 can be used to find the probability of drawing the Jack of Spades. So basically what we're going to do is, let's see, let's look at it here. Think of drawing the Jack of Spades as a simultaneously occurrence of events Jack and Spade. So rule 2 gives probability of Jack and Spade. Okay, so this is rule 2. So this is going to equal the probability of a Jack times the probability of Spade. Okay, so when you do that, this is going to equal the probability of Jack is going to be 1 out of 13. And the probability of spades is 1 out of 4. And this equals 1 out of 52. So that's just using that. Now, let's look real quick at rule 1. Rule 1 could be written like this. All right, and basically what this form means, we can calculate the probability of B given condition A as probability of A and B, and that means intersects B, divided by the probability of A. Now, so that's basically saying in a Venn diagram, since A probability of A is known, event A is known, so this is A, this is B, and B I'll put in green here. We can ignore everything outside the A circle in the diagram. So the probability of B given A is just a fraction of A sample points that are not in B. So that would be these in here. So that's the Venn diagram for this. All right. Now let's answer the final question. Are the events Jack and face card independent? So basically, we're going to do the probability of Jack. That's going to be, we have 4 out of 52, which equals 1 divided by 13. Okay, now let's do probability of Jack, given that we drew a face card. So if we draw a face card, we got to look at that first. There's only 3 times 4 face cards. So that's going to be 4 face cards divided by 12. And that equals 1 divided by 3. So since probability of Jack that these don't equal, the events are not independent. And that's it. Thank you. Have a nice day. Bye-bye.